watch a video first that I have taken by a mobile. Here you can see a value on that HMI KTP 400 basic as a kg, means it's a load, and that load coming from wave bridge, and wave bridge from wave bridge load cell connected to a Siemens SOARX module WP231. Here this is a SOARX WP231 module, and beside that owing module there is a switch. You may think that why here is 4 cable. This is a 5 port switch, but here we have used 4 port. Why? Because it's this module connected to our PLC. So this cable come from PLC, another one written as a PC, that is going to is PC, another one wave bridge controller, that means this one going to this owing controller, and there is another cable, that is red one, which is goes to HMI. And see, owing controller Siemens SOARX WP231, and this one is the terminal for RTU, Modbus RTU. Here this one jumper, this one is a this one jumper for point to point communication. We don't need this terminal, so we have jumpered it. Only we need plus D plus and D minus, that is connected to terminal. Okay, and from that LAN port it's connected to switch. This is a KTP 400 basic, and it's showing -10, means bridge is empty now, and this is a SCADA, and that value is showing here. Okay, okay, see that value bulker weight is now -10, that taken from the module. Now our motto is how we can take the data from that owing controller, to our PLC. We can take data from that owing controller to PLC by 3 ways. One is by using milliamps, another is Modbus TCP/IP, another is Modbus RTU. For today we will discuss about Modbus RTU protocol, how we can program for taking data from that owing module. Okay, before we do a program, let's see which register has the data, gross or net weight data. Here I already opened the module, owing module manual, that SOARX WP231, and this manual number is this one, and we'll take the gross or net weight, and which is a float value. Okay, and you know the float has a 4 byte data, and that register is 3014. One thing you keep in mind, that all the register is a holding register, and that is extended holding register. Okay, now go to TIA. Here I have already taken a PLC as PLC2 CPU 1214C, but by actual we have the 1214C DC. I will show you. But how we can configure? We cannot show in real PLC because it's running now, so we will show here. Okay, after insert your PLC. Okay, I'll open device configuration dialog. here Modbus communication card. Over here there is a space to insert a card. Okay, so owing card you have to add here, Modbus owing card. So from that hardware catalog, from communication, point to point communication means one will be master, another will be slab. That is a point to point communication. There is not multi point communication, means a bus communication, only from the master to slab. Okay, so PLC will be master and owing module will be slab. And you know that master will initiate the request, master request to slab, and slab will respond. Means master will request for data, please give me that data, what is the value right now. So slab will respond that please take that data, this is the value of that registered data. So by this way Modbus data will take. So we'll use that one over here. Okay, now here you have a module, that is the communication for RS485. So you have, there is a configuration tag, you need that for programming. Okay, that one is the system constant, that port number. You need the hardware identification for communication. Without that hardware identification number, the communication not initiate. Okay, so you can give directly to 269, better to use that tag. Okay, now go to program block. Okay, will not use another block, will directly program on that main OB. Okay, now first you have to initiate the port configuration. Okay, for initialize you need a block name as MB com load, MB com load. Okay, see that block MB com load under communication under Modbus. Okay, and you have to give a request number, request tag, that is boolean tag. So you can use a tag that will only scan for once, means only give a one request. Once it is established the communication, you don't need to give another request. If you generate request again and again, your data will lose. So here is your port number that I already show you from here, that one. That one is your port number. What is, okay, that one will be your port number. So here you have to give a port number. Okay, better you can use a fast scan number. Okay, we don't configure, so you can use a tag that is GPT. Here you can give a tag that always one, or you can give any tag that with 10.0. better to use fast scan For that you have to configure your PLC. I didn't configure because CPU here, system and clock memory, this one. So first cycle, you can use that first cycle. So when your CPU will goes from stop to start, this bit M1.0 will high, later it will goes to 0. That will be okay. Or other way, if you use another tag, then 1.0, then you have to use a trigger bit. So if you use first scan, you don't need to use the rise stick. If you use another always on or always off, always on bit, then you have to use a rise stick. Means after rise stick it will give only one pulse. Okay. Now baud rate. Whatever you baud rate set on that weighing module, that you have to set here. Better to use 19200 that I have set, and parity set as even, that is 2. For 0 it is parity none, and for 1 it is parity odd, and for value 2 it is parity even. And here you have to give a Modbus DB. Okay, later I will give a Modbus DB here. Okay, now I will here MB slab, that is Modbus slab communication. Okay, here it's showing a Modbus slab DB. That Modbus slab you have to use here. Okay, now here you have to give a address. Sorry, it is not a Modbus slab. This means your PLC will be Modbus slab, but your PLC is a Modbus master and weighing module is a Modbus slab. So here you have to use a Modbus master. Okay, that Modbus master block DB you have to use here. Okay, and that request you can give always, or you can use a pulse. Modbus address, as I show, train, and for data read from the slab it is 0, for write it is you have to put 1. So now I want to read the data from my slab, so here I have put it is a 0. Okay, and here you have to put the Modbus holding register. So here we have a address that is 3014. Okay, but 3014 is a holding register. So holding register, and it is a extended holding register, so it's a 4. If you take from 3014 and 16, then you have to take 8 byte. So if I use a 4 data length 4, so this is a register. Each register is a 1 word. So 4 means 4 register, means 2 4 word, 2 double word. And here I will use a DB block. Okay, DB, that MB data. Okay, use as a array of the word. Okay, means here is a 0 2 double word. 2 double word means it is a 4 word, means 8 byte. Okay, you can just use like this. I'll make it plot. Yeah, you can use like this, so it will take only those. Also you have to use the status tag. By the status tag value you can find out if there is a error, then you can find out what is the problem. Okay, now MB master status, and that is a integer. Okay, I will put here. Second, also I will put for MB com status. Okay, so this way. Okay, here you can use direct as a always true. If you want to write some data to that slab, then you should not use always true. Means you can use a pulse like this. Okay, let me check. Okay, pulse number, enable clock. Okay, so you can use M0.3. okay, for every 500 millisecond it will read data. Now let's go to real PLC and see how I have programmed. Same way I have programmed like this, but for the time being I have disconnected the cable because I have used the TCP IP communication. That's why I have disconnected. Okay, later I will show how I have connected. Okay, see, this is our real PLC. I have used a fast scan here, and see the local CB, the address 272, baud rate 192.002, and this is the Modbus DB number. This one is the DB 124, that one also. Okay, here you can see the status is 0 because it's inactive now. But here you can use that tag or not, that is not issue, but you should use that status tag. Okay, and the Modbus address, bus address is 10, mode is 0, and this is the start address of that data. From that address 4 data length 4 is used, means 4 word means 2 double word is used. Here you can see we have used that way also, db122.dbx22 from byte 0. Also you can use. Okay, let's see db122. Okay, this is a Modbus data db122, but from that db122 start address is dbx. It is a Modbus RTU, but start address is 2626. If I just select, drag and drop there, that also will work, but here we have used as a pointer, so from that point, for that pointer start address is 26. Okay, from that 26 it will take 8 byte. It will take 8 byte, right? 8 byte means 4 word means 2 double word. Okay. Okay. 0. That's way we have used. Okay, but here the data use as a double word, but your value is real float value. So how we can convert that double word to real? You just use, okay, I am going back here. You just, okay, just use double word to real converter. Okay, here just double word and here is real. Okay, and here is your data block 1, this one. If you want to convert this one double word, go. Okay. And here will be your data from owing module over Modbus. That's it.